Okay. All right. So I kind of want to discuss some of the fundamental things that are associated with networking or networks. So that means we're going to talk about networking concepts. We're going to talk about networking devices. We're going to talk about the purpose of networking really is to send messages back and forth to different networks or different individuals. And we're going to talk about the tools that allow you to do that. So that's what this class is going to, that's what this session is going to be like, just an overview of networking devices and networking theories, as well as concepts on how our messages can travel and reach its destination. So we're going to compare devices such as switches, hubs, cables, modems, and routers. And one thing I always tell my students that this is information that you already have and that you already know and that you already experience. It's just sometimes people don't break down the content to us or they don't break down the algorithm. I'll say it like that. How do we deprogram the algorithm or deconstruct the algorithm in order to understand where we lie or where our position is in this network or this network space that we talk about? As I always tell my students, the whole goal of this is to really emulate human life. We're trying to send messages to one another. You have a network, a group of friends, a group of individuals that you share information with. You may have one, give me a second. You may have one individual, and that individual or groups of individuals within your network will spread out to other networks and share information with those networks if necessary or need be. You want to go to a party, an event, a football game, or something like that. A friend will talk to a friend, or as we used to say, tell a friend, tell a friend. And next thing you know, everybody's meeting up so that they can go somewhere. Same thing with our messages. It's just what types of mediums are we using? And when I say mediums, I'm talking about cables, whether it's fiber optic, whether it's copper cable, things of that nature. Or is it fiber optic, copper cable, or radio frequency waves? We refer to those as mediums. Okay. So, and then you have your devices that we use to send messages or control or regulate messaging as well, such as routers, switches, hubs, and then we have servers that offers a service. Okay. Conceptually, we're going to talk about two models, the OSI model and the TCP/IP model. The OSI model is a teaching model, and the TCP/IP model is what we actually use. TCP/IP stands for Transmission Control Protocol. IP stands for Internet Protocol. So you have messages that govern the sending and receiving of your message, and then you have messages that govern which direction your message will travel, how it will travel, and how it will get there. Okay. So this is the overview of what we are going to pretty much be talking about. So when we think of TCP/IP, and we're going to kind of focus on Windows networking, because typically when you look at the CompTIA exam, we look at Windows. Even though we'll touch on Mac, we'll touch on Linux and things of that nature, we want to define a couple terms that will allow us to understand what we're talking about. Okay. So here's some terms here: a host and a node. And as you recall, last time prior to us, before the break, I said a host is a computer that can either be the client or the server. All right. In networking, we look at a host as any device that can have an IP address. Okay. And a node is any computer, printer, or other network device that's attached to that network that is basically supported by that network. It could be a telephone or something like that, any device on the network. A host and a node are interchangeable, but they're two different things. We will look at port addressing, port numbers, and as you all know, some of you may know, the transport layer is of the OSI model, or TCP/IP model is where we get our port numbers from. And Professor Helton's definition of a port is the door in which your message has to travel. So on the network, there's a particular door or a port that gives you access to a particular server. Okay. So you have to port into that server's world, whether it's a web server, file server, whether it is a I don't know, logging server or something like that. Your IP address identifies a node and its network connections. I often tell my students that an IP address will basically inform you of the route or the road or the group of routers that your message has to travel through in order to reach its destination. Your MAC address. Your MAC address identifies what we call a network adapter or an Ethernet card or a Wi Fi card or a Bluetooth card that is connected to your computer. And this communication card allows you to send signals back and forth. Okay. Your MAC address is a number, a 12-digit 48-bit number that is on the network interface card. Now, very quickly, let me give you some images that are associated with network interface cards. And just say networking. All right. So this is an image or images of network interface cards that are connected to your computer. As you see here, this is an Ethernet network interface card. You can have wireless network interface cards. Okay. On that network interface card, you'll have a number. So I'm just going to put wireless NICs and MAC addresses. So here's a great image. On this image right here, I wish I could make it a little bigger though, but let's go here. There we go. That's good. And this looks like one for a laptop. This network interface card here has a MAC address. And these digits right here, the first 6 digits are identify the manufacturer of the network interface card. And then the last 6 digits represent the actual company. Okay. So we refer to this as a physical address. Your IP address is a logical address. As you can see by this statement right here at the bottom, MAC address is a physical address and IP address is a logical address. All right. Here's another network interface card for a desktop computer. Okay. So your MAC address, your IP address is on your hard drive. Your MAC address is on the network interface card. Okay. And you need this location information in order to send messages. Your host name is your computer name that identifies a host and can be used in place of its IP address on the network. So whenever you hear the term host name, they're talking about the name of your computer. If you go to your about set, go to settings. If you go to settings and you pull up system and go down to about, you can get the name of your computer. But if you go to CMD and pull up your command prompt, if you IPCONFIG, you'll pull up the actual host name of your computer. And for privacy's sake, I'm not going to do that for my computer. But you can pull up your IP address, you can pull up your host name, you can pull up a number of different things. Okay. I think I can use a question mark here. Nope. Just type help. If I type help in the command prompt, it's going to give me a bunch of different commands that you can go through, okay, or go to, or actually learn more of what you can do in the command prompt if you needed to fix or gather information or search for something. Just real quick, how to find your host name in Windows 11. All right. So if you want to define your host name on Windows 11, click on the search icon within the taskbar, type settings in the search bar, open settings, select system settings. If it is not selected automatically, the computer name will be listed within the system window. Okay. So that's going to be your host name. Okay. And that's finding your computer name. I want to move towards your host name or finding the local host. Now, here's how you can find your local host. If you I'll physically go here. All right. Here are some of the steps. don't want the computer name. I want the host name. I know ipconfig is one, but I was just trying to find another quick way that if you ever needed your host name, you could find the local host on your computer. I'll research it and make sure you're able to get that. All right. Then we have what is called a domain name. Your domain name identifies your network. And remember, we talked about a domain being a group of computers that is basically managed by a central networking device. All right. And that typically is a switch, excuse me. And a fully qualified domain name identifies a computer and the network to which it belongs, such as www.cengage.com. So your FQDN is this URL right here. Okay, that's your fully qualified domain. All right, we just took a look at a network interface card. On this network interface card, you're going to see that you have a MAC address right here. It says this gigabit Ethernet adapter by Intel uses a PCIe slot, and it has that information addressed on there. Your TCP/IP model. All right. So you have a suite of protocols or rules that define network communication called the Transmission Control Protocol / Internet Protocol. Communication between two computers happens in layers. You have the application pass, which passes a request to the operating system, which passes the request to the network card and then onto the network. That's just a fast way of trying to explain what it actually looks like. So in the TCP/IP model, we look at protocols by the hardware function at what we call the link layer or the data link layer. So the data link layer or your network access layer, which I will show in a minute, is where you have your physical connection. It said in protocols used by the operating system are divided into three layers: your internet layer, your transport layer, and your application layer. So you have a hardware portion, and then you have a portion that is going to look at the operating system. So operating system portion and a hardware portion. Okay. Let's see if they hack the actual breakdown. That is too small. Let's see if I can make it larger. Jesus. So as you can see here, I'm gonna pull up another diagram. So as you can see here, network communications happens in layers. You have your application layer, where your computer is going to use a driving protocol, and from that driving protocol, you're going to start crafting your message. Then you have your transport layer, whether it's a TCP or UDP communication or message. Then what's going to happen is you'll get an IP address after that, and then your link or your hardware portion, which will access the network interface card, is going where you're going to get the MAC address, or you'll have your cable connection or your Ethernet connection. Give me 1 second. I'll find a better image. TCP/IP model image. And let's use this first. Here's a great comparison image between the OSI model and the TCP/IP model. Hold on 1 second. Okay. So, uh, in our previous class that we were in, we went over the functions and each layer of the OSI model. And something to help you memorize the OSI model is please do not throw sausage pizza away. So that's the mnemonic for that one. Please do not throw sausage pizza away. But you have your application layer, your presentation, session, transport, network, data link, and physical. Application layer, your driving protocol, such as HTTP, SNMP, things of that nature. That's why I always tell everyone you got to know your 20 most common protocols. Let me see if I actually have it in the file section of the course. I may not. Uploaded media, binary conversion. I don't. So I can easily find that. I think I have it on a computer somewhere. 40 most common ports and protocols. I have a list in another class, but um, I'm going to do that list because that list is more detailed. So give me a while and I'll put that in this course after we wrap up today. All right. Where was I? Oh, the comparison between OSI and TCP/IP. What image was going on? There we go. All right. So as you can see, the first three layers of the OSI model are compared to the first layer or the fourth layer, excuse me, of the TCP/IP model. So you have your application layer, which is the application, the presentation, or where your message gets encrypted. Then you have the session layer where you get a session number. Okay. Then you have your transport layer where your message is determined to be either a UDP or a TCP message. Then those are the two protocols that sit there. Then that message gets segmented or moved or broken down into smaller chunks and receive a sequence number. Okay. Not only do they receive a sequence number, you get a port number. So a lot of things take place at the transport layer. Then you have your network layer, which we normally in TCP, we normally call it the internet layer. But for this model, this um, graph right here, they put network layer. You get your IP addresses assigned in this layer. Then you have your data link and physical layer of the OSI model, which is your network access layer. This is your network interface card layer. Okay. These layers look at the MAC addresses, they look at the cabling, they look at the sending of message, the transferring of messages into bits. So that's what takes place here at this layer. And this is just a more descriptive breakdown of the layers. So layers 1 is the physical layer, 2 is the data link layer, 3 is the internet layer, and then you have layers 4, which is the transport layer. This is the OSI model. Layer 5 is the how did they do that like that? The application layer. That's off. See, that's why you can't go by everybody's diagram. This is 4, this is 3, this is 2, and this is 1. 4 is the application layer, 3 is the transport layer, 2 is the network layer, 1 is network access. Okay. So that's that we're getting ready to get a little more in depth with that, but not using their graphs. Bad. All right. This one, this graph is talking about the purpose of a router and a host. Okay. And the router, as you see here by the graph, as you can see here by the graph, the router is allowing the individual to create a bridge between another network so that you can actually send your messages on that network. So this router is going to direct them if they can send a message or not. What I want to do is I want to show a quick video in regards to some of this information. All right. So if you give me one quick second. Let's do a quick overview. Networking, networking overview. All right, let's do a quick overview. Watching this video right here. I think, let me stop my share and bring it back. I just want to see if I have it on right. Yeah, I do. All right. Let's get to it.
In today's world, practically every computing device we use is connected to a network. A network is just a group of interconnected computers and devices that share information with each other. By simply connecting to the internet, you've automatically joined the largest network in the world, since the internet is just made up of a bunch of computers that share data with each other. In this lesson, we're going to look at a network's components, cover network addressing, and go over some of the benefits that come with networking. Setting up a network requires a few different components. The first is the devices that we want to have talking to each other. These devices can be our computer, tablet, mobile phone, gaming console, IoT device, or server. We often refer to these as network nodes or hosts. Once we have our devices, we have to connect them all together. Devices on a network can be connected using a variety of transmission media. We can use twisted pair cabling, fiber optics, or even wireless radio signals. To use a specific transmission medium, a device needs the appropriate network interface. The interface's job is to convert the digital data flowing in and out of our device into a signal that can be transmitted on the network medium. For example, if we're using twisted pair cabling, our network interface needs to have the appropriate connection for that cable. Each device on the network has to have a network interface to send and receive data. In the old days, networks were often small, and we could directly connect devices to each other. Today's networks are much larger and work better by having a central connection point, such as a switch. For wireless networks, we can use an access point to connect everything together. We can also use a router to connect multiple networks together. The final piece of a network is the standards that will be used to define how the data is formatted. These standards are known as network protocols. If devices aren't using the same protocols, they won't be able to communicate or understand each other. You'll see different protocols depending on the network and type of data that's being transferred. Tying all these components together allows us to design our networks the way we want, no matter how large or small. Once we've got our devices physically connected, we need to configure the network addresses so that each device knows which network they're connected to. If you think about it, a network is just like a neighborhood. Every device has to have a unique identifier, just like every house on a street does. This unique identifier for a building is an address, and every address on the network has its own address as well. For example, Test Out is located on a street named South Main Street, and our building number is 50. If we break down this address, 50 is the unique building number that distinguishes it from all the other buildings on South Main Street. Now, another building on the next street over can also have the building number 50, but because it's on a different street, it shouldn't get confused with ours. We can apply the same addressing principle to networking. Each network address has two parts: the network ID, which is equivalent to the street name, and the host ID, which is the unique building number. A network address is written out using an IP address. We have two types of IP addresses: IP version 4 and IP version 6. For now, we'll look at IP version 4. Here's a typical IPv4 address. Each section of this address is called an octet because it consists of 8 bits, or ones and zeros, and each octet is separated by a period. The first 3 octets here represent the network ID. This means that every device on the network will start with 192.168.1. The last octet is the host ID and will be different for every network device. Depending on the network size, the first 3 octets won't always represent the network ID. Sometimes it's just the first 2, or even just the first 1, and remaining octets are the unique host ID. We can look at the subnet mask to know which octets are the network ID and which are the host ID. The subnet mask is important to the IP address because it gives context to which network or subnet it belongs to. Each octet in the subnet mask consists of a value that identifies the IP address's network portion or host portion. If the whole subnet mask octet is identifying the network, a value of 255 will be indicated. If a subnet mask octet is 0, that always identifies the host portion. In this example, the subnet mask has a 255 value for the first 2 octets, and since there are zeros for the other octets, The two 255s identify 192.168 as the network ID. The host ID consists then of the last two octets. In this case, that's 0.50. When you look up a device's IP address, the subnet mask will also be displayed so that you know which portions of the IP address are which. This information helps you troubleshoot any communication issues you might be experiencing. Oftentimes, we have one large network, and it makes more sense to separate it into smaller ones. Each of these smaller networks is called a subnet, which is kind of like a street. That's why we need the subnet mask. It's what lets us know which network our devices are connected to and what the IP address should be on that subnet. For two devices to communicate, they need to have a unique IP address. If they're part of the same subnet, or same street, as it were, they'll be able to easily communicate. If they're on different subnets, the traffic will need to be sent through a router, known as a default gateway, which will then forward it on to its destination subnet. This is why it's important to verify the network IDs and to make sure that your devices have the correct IP address and are on the correct subnet. Setting up and configuring a network takes a lot of work and can be complicated, but the benefits make it worthwhile. One of the main benefits is the ability to share resources like files and printers. Sharing resources allows you to be cost-effective while still providing the necessary resources to your users. For example, everyone needs to print stuff off occasionally, but it's more cost-effective to have a single printer for multiple users instead of giving each user their own. Networks can also consolidate storage. Instead of requiring employees to store data on their local workstations, they can save data in a central location on a file server. They can even save data on a network-attached storage device. Being able to share files over the network makes collaboration easier. It also makes it easier for the network administrators to back up and protect important data in case there's a disaster. Implementing email, instant messaging, or even social media allows users working on a project to collaborate with each other no matter where they're located. We can add workflow management to the mix to help track projects and organize them more efficiently. From the administrative side, a network makes management a whole lot easier. Instead of having to go to individual computers to back up data or troubleshoot, you can handle these tasks remotely. The network also provides a centralized management location for user accounts and security. There are many other benefits to networking that you'll discover. The ability to connect our devices together to share resources has transformed how organizations operate. To be a successful technician, you absolutely must be familiar with networking. That'll wrap up this lesson. In this lesson, we first looked at the different components that make up a network, including the transmission medium, the interface, and others. Then we went over the basics of network addressing and how an IP version 4 address is formatted. Finally, we covered some of the benefits to networking, including sharing resources and having a central location for administration.
All right. So now, if I go back here, so that was just an overview of the where did the PowerPoint go? An overview of networking. Okay, talked about IP addressing, talked about the different types of devices associated with networks, the purpose of networks, and some of the devices that are associated with networks as well. Like routers, route remote networks. They use different subnets. Okay, a subnet mask is like a container for a network. An IP address, as you saw the part about the IP address, an IP address has two parts. It has a network address part and it has a host address part. Okay, and when you saw those zeros were associated with the host portion, and 255.255 is associated with the network portion. The 255, the full bits of 8, actually shows you when what type of network you're going to have, what network address a particular host can have. Here's what I mean. Give me 1 second. Change my share. Go to my whiteboard. Computer's moving kind of slow. Oh, I was talking and didn't know my mic was off. Everyone can see the whiteboard, correct?
Yes.
Okay. Tony, Tyler, can y'all see the whiteboard?
Yeah, I see it.
Okay. All right, cool. All right. So when we're talking about the IP address, such as, a 192.168.1.1, this is a class C IP address. And the reason it's a class C IP address is because it sits within a class C subnet, 255.255.255.0. And that class C subnet, where the 0 is the host portion of the IP address and the 255s represent the network portion. These are series of eights, all eight. When I say eight, I'm talking about 8 bits. Bits are a series of ones and zeros. So 8 ones, if you add all of your ones together, which the ones and zeros are denoted by a value of 128, 64, 32, 16, sorry, 8, 4, 2, and 1. If you add all these values together, you would get a value of 255. Okay. Then what we did not include is 0. So in this structure for IP version 4 and a series of bits, 0 through 255 equals 256. Okay. With 0 through 255 equaling 256, what we now have is the total number of bits for addressing or assigning IP addresses. But any IP address that ends in a 0, which means that this last octet here, if it ends in a 0, that's normally associated with what we call a network address. So 0, or any IP address ending in 0, is associated with network addresses. And if an IP address ends in 255, we refer to these as broadcast addresses. Now, my question is, before I go any further, is this common knowledge to all of you already?
Yes, pretty much.
Okay,
We
so
learned
A
that
little bit.
from the other class too.
right, because we've talked about this in other classes as well. All right,
Yeah,
so this is
it's
your
kind of
network
repeat for
address.
me.
Say it again.
It's kind of repeat, sort of.
Yeah, that's fine.
Yeah.
So this is the network address and this is your broadcast address. So if I ask you all if you were able to convert, so let me ask another question. Are you able to convert binary to dotted decimal and dotted decimal to binary?
Yeah. I
Okay.
remember that activity that we did
Earlier, right?
earlier.
Okay.
Yeah, earlier in the semester.
Good. All right. Good. So with this being like this, there are different classes of IP addresses. Does everybody know their classes of IP addresses?
Class A, Class B, and Class C.
Okay. And with that being said, let me draw another one. All right. A, B, C, D, E. Can you give me the different ranges of the first octet of an IP address for each class? Because I think maybe I think we need a quiz so I can see where everybody's at. Does anybody know? And we just want to do it like this: public IP addresses. Does anybody know the ranges? So it starts from 1 to 126, 128 to believe it's Class C starts to 224 to 223. I hate when it does it like that. I'm gonna have to change the sizes. Then 224 to 239. Then there's 240 to, sorry, 240 to 255, I believe. This would be 239. I'm messing up. I'm sorry. This would be 128 to 191. Class C is 192 to 230, 239. Fix it right here. Font is so big. All right.
Oh, Professor, we cannot hear you.
Oh, it's 192 to 223. Then this is 224 to 239. And then class E is 240 to 255. Okay. So these are the classes of public IP addresses. And really we're focused with the first octet. So in this example that you see right here, where you see 192, you see that that's a class C IP address. So 255.255.255 would be a particular, subnet. Let's see if I can duplicate this. Duplicate, and we're going to make changes in this one. So private. And you have your private IP address ranges, okay, of IP addresses. And there's only 3 classes of these. Classes A, B, and C, and which will be a 10 dot network. This will be a 172 dot network, and this will be a 192 dot network. So there were certain address ranges that were pulled from the network so that you can save IP version 4, okay? Because IP version 4 got used up, all right? Now, when it comes to the subnet mask, okay, over here, then you have subnet IP address ranges, subnetwork mask IP address ranges, all right? And with those IP address ranges, they determine what your IP address is going to be, which is not the one for that. 0.0.0.5. Do y'all understand what I'm getting at here? And
Yes,
so
yes, yes.
some
A
of
little bit.
the information that I kind of want you to understand. All right. So for a particular subnet mask, the subnet mask is going to determine what private IP address you're going to use. The subnet mask will also determine what public IP address you're going to use. Now, does not determine subnetting, but this is a chart that I typically have a lot of students memorize and learn when they're in some of my networking courses, because I kind of want them to understand the concepts that drives IP addresses. Now, I have a question for you. If I look at this subnet mask for a class A, which part is the network portion and which part is the host portion? So here are subnet masks right here of class A.
I think 225, 225, all threes is the IP, and then 0 is the other one.
Okay. Anybody else?
Based on test out video that you show us.
Mm-hmm.
I don't.
Okay. So if it was a class A, sometimes I'll create a chart that talks about the relationship. Get out of here. That talks about the relationship, the network to host relationship. So 255 is going to be determine the network address. Okay. The zeros will determine the host or the number of hosts that we can actually assign an IP address to. This 0 can be anywhere from 0 to 255. But we know that 0 we typically use for network addresses. 255 is used for broadcast addresses. So if I have an IP address in this range, let's use I'm gonna do a text again. Let's use this IP address of 1.5.0.255. If I use this IP address here, this would be a broadcast address for a computer. But these three values here are for the host. They can be anywhere from 1 to 255 or 254 because we don't want to use 255. That's a host address value. Or it could be 255.255.254. This would be the last available IP address on the network. So I'm going to stop here because I don't want to stay stuck on here in terms of IP addressings. And then this is just an overview. Okay. And to get people to kind of understand this concept of IP addressing. Give me a second. I'm going to switch back to my screen. All right. Hopefully you can see my screen. So this is the content that we're talking about here. So it's a lot of information, especially when you want to try to understand how our messages go from network to network to network. So far we've talked about IP addresses, MAC addresses. We've talked about the different forms of IP addresses, classes of IP addresses. Let's move on. We kind of brought up the OSI model. I want to kind of talk about it briefly again and the difference between the two, which we did state earlier, that you have 7 layers of the OSI model, which is a teaching model, which leads into different layers of the 4 layers of the TCP/IP model, or what we really use. Okay, so you have your application, presentation, session, transport layer, network, data link, and physical layers, which leads into our application, transport, network, and network access layer. Okay, moving on. We understand that servers provide services such as web servers, mail servers, file servers, and so on and so forth. That's why it's good to know our ports and our port numbers, because those port numbers are associated with certain networking protocols. Okay. Does anybody remember that the DHCP server is used to automatically assign IP addresses to networking computers? As it says here, devices can request an IP address from a DHCP or dynamic host configuration protocol server that assigns addresses from a pool of addresses that it maintains. And you have other protocols that you should understand. One such one is lightweight directory access protocol. When you get a job and you work in certain areas, your information will be added to a database. And then while you're in that database, they'll assign permissions to what you can access and what you can't access. Like, I'm pretty sure that y'all are on a student database. And while you're on that database, your information is protected because you have HIPAA laws, you have FERPA laws. There's a lot of things that come into play when based upon the industry in which your information is going to be stored. FERPA is more associated with school systems. So a proxy server is a computer that intercepts requests that a client makes of another server. A proxy server is a mail server that filters traffic. Okay. You have syslog servers or a system log server that collects information about errors, failures, maintenance, and all of that so that you can analyze what is called benchmarks and then make different changes on the network. You have your FTP or your file transfer protocol server, and there are other protocols that I'm not going to go over because y'all said y'all know it, right?
Uh,
That's the way y'all approach it. Y'all approach it like I'm giving y'all information y'all already know. So I'm trying to see. I think I'm going to do a test. So the test that we're going to do on Monday is going to be a test to see what you know. Because
On
I
this
want to
on this
on,
chapter,
I'm going to do everything. I want to see what you know on everything.
everything you mean by from beginning?
From any, I'm gonna give you the whole full test on
Okay.
Monday.
Okay.
I'm gonna open up the test. I'm gonna say, take this test.
Oh, okay.
Actually, you know what? I'll give it to you over the weekend. And I want you to
That's
take
good.
it. Some of y'all probably already took it, but I'm gonna give you the option to take it again because I want to see what you know.
That's
All right.
good.
Um, so and the reason you may think I'm being a little pushy, but I'm sorry. It's a very competitive market. So it's a lot of information. People overlook this information, and when I stand up and try to teach it, everybody. I don't want to generalize everybody. A lot of people assume that the hands-on learning is going to get you to where you need to go, but you have to have a combination of hands-on as well as conceptual learning, because there's a lot of things that you're going to coming into you're going to encounter, and you never know what scenario you may be in and what information you may. It's been times I was in a class and I said, and then I had to do something. I said, wait a minute, that's what my professor was talking about. Or I learned that when I read this, or I saw something on YouTube, and I was able to answer a question. So that's just coming from that perspective. So you have different protocols. So all of these are protocols: files transfer protocol, your telnet server, which is, anybody know what port number telnet is without searching the internet?
isn't it? Uh, wait,
Port number.
port number. Um, hold on.
80?
Nope. That's HTTP
Okay.
port 80.
40? No.
43.
43 FTP? No.
Um,
44.
Ports 20 and 21. Now bear in mind,
Oh.
I've been teaching this a while, so it's fresh on my brain. Okay,
Mhm.
but ports 20 and 21. So if you're going to use an FTP server or go to an FTP website to transfer information to someone else, you're going to access that through ports 20 and 21 on that network. Telnet is ports 23. Secure Shell is port 22. Remote Desktop Protocol is port 3389. Why is that important? Because there's a concept called network hardening, where you want to shut down all the ports, or as us as humans, lock the doors so that people won't be able to have access. Because if I do a ping, you may say, well, Mr. Helton, what do you mean by ping? which I'm pretty sure you know in this long enough, if you go to command prompt and you come here and you type ping and an IP address and hit enter, it's going to send empty messages to gain information. If I reach an open port, I'm going to get a response. When I get a response as a hacker or ethical hacker, I'll say, I know that's an open port. So now I can say, let me get Nmat. And if I get Nmat, I can now scan that port. And if I scan that port, I can see if there's older operating system information on that particular port. So that's why knowing your port numbers is important, because from a scanning perspective, it provides information. Because in ethical hacking, when we learn about that, we're looking for open ports, we're looking for operating systems, even older operating systems, we're looking for DNS servers, we're looking for information that's going to give us access, a higher level of access into a particular system. So that's kind of why one reason why knowing your port numbers is very important. Um, Now we went over this earlier, Gila and I, about the difference between TCP protocols and UDP protocols. TCP protocols reaches its destination and gives you an acknowledgement that it reaches its destination. UDP does not do that. UDP is what we call connectionless. TCP is connection oriented. TCP is used for broadcasting, where guaranteed delivery is not as important or as a fast transmission. In other words, streaming is a UDP communication. Hold on for a second.
You had a very good chart, actually. I wrote it down.
Earlier today?
Yeah, earlier today. Um, it's very distinguishable. TCP and UDP. The chart, it was like one TCP was a secure, the other one's unsecure. TCP
Yes.
was slow, and then the other one's fast.
Mm-hmm.
What was a flow chart wasn't like flow chart something.
This one right here. The differences between the two.
Yeah, that's the one.
Yep.
Sure.
Computer's acting up. Here we go. Where TCP communications are connection oriented, slow, guaranteed transmission used by critical applications. There's a packet reorder mechanism, which means they're going to go in a certain order. There's a flow that's associated with it, or flow control. When we talk about flow control, we as humans use flow control. When you look up at the stop sign and the stop sign, or when you're going down 695 and the sign will tell everybody to slow down so that traffic can keep going, or it'll tell us like there was an accident, be careful about your transmissions. Hold on for a second. Hello. Yep, I'm back. So these are things that we consider or think about when we're talking about the difference between UDP communications, user datagram communications, and TCP communications. So streaming would be a TCP, a UDP communication, and like leasing from the DHCP server would be a TCP communication. A DNS is a TCP communication. FTP is a TCP communication, a very critical application. Okay. All right. Moving on. And we all understand the three-way handshake, correct?
Yes, you
Can you elaborate on that?
three ways.
I ain't never heard that one before.
Oh, you never heard of the three-way handshake?
I
Okay.
ain't heard that one. It might be something I'll probably like learn about maybe, but
Yeah.
I've never heard that specifically, like that term.
Okay. All right. We'll elaborate on it.
Yeah, you explained this morning for us
Yep.
for the class.
Definitely.
Three ways handshake.
Handshake. Okay. So here's the three-way handshake that typically takes place 3 to 5 days, and we don't even realize it. Okay. So when it comes to the three-way handshake, you have a PC. Okay. And your PC is going to send communications to a particular server. Sorry for my drawing. So your PC is going to send a communication to the server. It's called a synchronization message, or we refer to it as a send message. Hold on for 1 second. Okay. This is a synchronization message from the PC to the server. All right. We're going to look at this as the DHCP server. That's supposed to be a VER. It's hard to write this with my mouse. Then from the server to the PC, you have what is called a synchronization acknowledgement message, or a SYN-ACK. ACK. Okay. The server will take a portion of the synchronization message from the PC along with this acknowledgement message and then send that back to the PC. Then on the third conversation, the PC will send an acknowledgement message back to the server, an ACK. It will send this message back to the server. Okay. We refer to this as a three-way handshake. Now, in this communication, there are things such as flags that are taking place, and flags help to stop a conversation. This acknowledgement message will come back with a finished flag, a fin, and there are different types of flags. There's a push flag, there's a finished flag, there's a reset flag or RST flag. There's an urgent flag, URG flag. All right, these messages will determine what's going to happen in this message or in this acknowledgement. This PC could decide, I don't want whatever you gave me. Let's reset this whole communication and start it over. Okay, so we refer to that as leasing, LEASING. So whenever your computer needs an IP address, which happens every 3 to 5 days, your computer will ask your DHCP server for another IP address. Once it receives that request, the server will say, hey, this is my synchronization acknowledgement message. I acknowledge that I received your message. Here's some IP addresses. Do you want these? And if they're part of a reserved pool, they will give that to the PC, and then the PC will send an acknowledgement message back to the server, just stating that we received this message and let's finish this communication. Thank you. Okay. So we refer to that as a three-way handshake. I got to get my pen so that I can start drawing better. Does that make sense? Hello? And this is what the DHCP server does. Okay. So PC, server, DHCP server, the communications that happens back and forth. And that's why it's also good to know that the server operates, the DHCP server operates on port 67 and 68. Ports numbers 67 and 68. Why is that irrelevant? Why is that relevant? Because one port is going to dictate the communication between the PC to the server, and the other port is going to dictate the communication between the server to the PC. Okay. So that's what that is. And that's called a three-way handshake.
Oh, we can hear you, Professor.
You mean I've been talking all that time and
Yeah,
I've been teaching my heart out. Oh my goodness. Um, sheesh. So you didn't hear
I
anything I
thought you
said?
were, you said something that you were looking for something. That's what we were waiting. From here,
No,
yeah. How
no.
computers find each other.
So I asked a question and no one responded, so I kept teaching.
Yeah, my bad. I lost service.
Okay.
No,
I'm in
And
an
then
area not that great service. I'm sorry.
so I don't know.
yeah,
Huh?
you asked question, but then you were when muted
I
and
think it muted on its own. Um,
oh yeah, maybe.
yeah, because I was rolling. Hot dog on
Yeah.
it, man. All right, so I'll backtrack. Um, so did y'all hear me talk about the IP version 4? and 32-bit addressing and what the 8 bits represent? I guess not.
I heard that part, I think, but I don't think about the other parts I didn't hear because it was just dead silent.
What a subnet mask is in a default gateway?
No, before that,
No.
Okay.
you were
Okay. That's when
showing
it,
the number. After question, you were showing the numbers,
Yeah.
1111, the binary,
okay.
and then it went silence.
Okay. So that's what happened. So we were here. So I was saying that the 4 numbers that are separated by a period are 8 values or 8 bits. Okay. Either ones or zeros. A combination of ones is going to give us 72. Now, that structure comes from the 2 to the power of 2. And what I mean by that is 128, 64, 32, 16, 8, 4, 2, 1. Those are powers of 2. 2 to the 0, 2 to the 1, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, 2 to the 7, and 2 to the 8 is going to give you certain values. So this system of IP addressing is based off the power of 2. Okay. Even though we'll talk about the metric system, and at least that's how I learned when my instructor taught me. I was like, what is he talking about? The largest possible decimal IP address is 255.255.255.255, meaning it's all 8 bits in binary. Then the um, the 4 numbers are called, each of them are called an octet. So zeros an I mean 255 is an octet, this 255 is an octet, this 255 is an octet, as well as this 255 is an octet as well, because it takes 8 bits, whether it's a 1 or a 0, binary, what a computer can read. As long as it's 8 bits, it's going to give you a certain value. And an octet can be any value from 0 to 255. Okay. What I was saying here is that to understand your subnet mask more, your subnet mask is an IP address that determines the network and host portions of the IP address. So if it's a class A, that first octet is the network portion, and the other 3 octets are host portions, meaning that I could use the last 3 octets to create IP addresses for a host. And you can have up to 16 million IP addresses for a class class A IP address. For class B, the first 2 octets are filled with 8 bits, 16 bits in total. 255.255, and you have 2 more octets that you can use to assign IP addresses. You can assign at least 65,539 IP addresses to a Class B network. Then, if it was Class C, you can only use 255 because you only have the last octet to use. So 255.255.255.0, the first 3 octets are the network portion and the last are the host portion. That's what they mean when they talk about that. I hope that makes sense. If not, please let me know.
Yeah, it makes sense, but I got a question. So
Uh,
how many IP addresses that can be assigned to like a server? You said that was the total for like a server or
no, for a
for the
particular,
subnets.
yeah, for a particular network. So you have to think about it not as a server per se. Think
Mm-hmm.
of it more like for a building or an office. So the Baltimore City like the school I used to work for, Digital Harbor,
Yeah.
you had, oh my goodness, I can't even tell you how many. It was 4 floors, 5 really, 5 floors, and we had how many? Over 80, was it 84,000 students? I mean 84,000. I can't remember. It's a lot. Um, you had a lot of students there. Since you had so many students, we used a Class A network. With that
Yeah.
Class A network, you can, and any school system building you go into, if you were to use IP config, you're going to see them using Class A. It's because that network is huge. Their internal network is huge. So they want to have as many IP addresses as possible. Here's the caveat. They could also have in one room, you could assign so many IP addresses because you might have multiple computers. So while they're using Class A, they also may be using Class C. So it's crazy to think about, but that's subnetting. So the size of the organization will determine what subnet mask you're going to use. So that's why I often say apartments are normally Class B, because you got to think about it. Let's say you have a 4-floor apartment building with 4 apartments on each side. Well, if it's 4, it's probably 4 in the front, 4 in the back. Then on the right side, then 4 in the front, 4 in the back on the left side. So that's a lot. And inside each apartment, you could probably have up to 255 devices running at one time attached to a network, but that depends on the network device. So it's not necessarily the server, it's how they want to set up the network and the thought process of the developers. So if the developer and the internet service provider and this is why IT and cyber is so important, because the IT networking technician, the networking technician, along with the HR and along with the managers will determine the need. So like if you and I started a business, we're going to have to pay the internet service provider for the number of IP addresses we're going to use. So if I only have 5 employees, I don't want 20 IP addresses because I'm going to have to pay for 20 IP addresses. So that's where the business part comes into play that people don't understand. So that's where subnetting comes into play, where depending on what part of the number of, I don't want to get into that. That's when we start getting a little, okay, I'll show you this.
Okay.
Let me show you this. I'm going to have to leave this class and go to another class and go to networking. Where's it at? Networking. When we go to networking, I'm going to go to networking protocols, network addressing. I think this is it. And subnets. Yes. Subnet facts, addressing assignments. Let's start here and see what they talk about here.
Yeah, Professor, I can't hear the video.
Yeah, we can hear.
Yeah.
Yeah, I'm fixing that now. Change the share. Change the share. What's going on? Okay. All right. You should be able to hear it now.
Breaking a large network into smaller subnetworks is the basic premise of subnetting. It's like taking a lake and making it into a bunch of smaller ponds. Subnetting has many benefits, including increased security, easier network management, improved network performance, and department separation. Let's look at the process of actually creating subnets. To keep things simple, we'll start with a small Class C private network with a network ID of 192.168.5.0 and a subnet mask of 255.255.255.0.
Now you see, that's why you got to know your tables. You got to know your subnet mask, your classes of subnet masks, your classes of private IP addresses, your classes of public IP addresses, and you also have to know what network address translation is. Network address translation is having one public address, and inside your network, you can have multiple private addresses. Think about it. You have tablets, computers, workstations, all printers, servers, all types of devices inside your network that are going to be running with different IP addresses, different routers, DHCP servers, email servers, things of that nature. So you need multiple private IP addresses, but the internet service provider is going to give you one forward-facing IP address that when you send your message out of that network, your router is going to convert that IP that your private IP address into a public IP address and send it out your network. And when someone sends a message into your network, that message will get converted into a private IP address and get sent to the right computer that should be receiving that message.
In this example, our goal is to create subnetworks that we can use for 4 groups: the accounting department, the management department, the human resources department, and the sales department. Since we only have one pool of IP addresses represented by this network ID, we need to borrow some bits from the 8 bits on the host portion and add that to our network ID. To see how this works, let's look at it using binary numbers. Our network ID in binary looks like this, 32 bits total. Our subnet mask consists of 24 ones, which represent the network ID, and 8 zeros, which represent the host ID. To subnet our network, we have to borrow some bits from the host portion and put them on the network ID. To determine how many bits we need to borrow, we use powers of 2. For example, if we borrow 1 bit, we calculate 2 to the power of 1, which equals 2. This means we could create 2 subnets. If we borrow 2 bits, we find that 2 to the power of 2 equals 4, so we get 4 subnets. Borrowing 3 bits would get us 8 subnets, and so on.
Now, if the terminology sounds weird, think about look at it as like one sheet of paper. We're now taking that paper and we're folding it into different sections. When we unfold it, it's going to have multiple sections. Okay. So one section is going to have a particular IP address or a subnet. Then the next section right beside it will have a different subnet. Okay. So that's what we're doing. We're going to borrow the last octet. So the first 0 has a value of 128. The second 0, 64, 32, 16, 8, 4, 2, 1. And then to do that, we're also going to subtract 2 from this. So the 2 to the 1 equals 2, but 2 minus 2 is 0. So we use that to determine the number of hosts that we're going to have on the network. So if I keep going, this is I think 2 to the 0, 1, 2, 3, 4, 5, 6, 7, 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, 2 to the 7. Okay. This one will be 2 to the 8. All right. And so on and so forth.
We only need 4. All we need to borrow is 2 bits. This now gives us 26 bits in our network ID and leaves us 6 bits to use for host IP addresses. So how do we get 4 different subnets by borrowing 2 bits? It's because each variation of the 2 bits we borrow from the 4th octet allows us to create 4 new network IDs, or subnets. Let's look a little closer. The first 3 octets won't change in our subnet mask or for our network ID, but the 2 bits we borrowed from the 4th octet gives us several possibilities. The first is to use 2 zeros, which gives us a network ID of 192.168.5.0. Next, we have the option of using a 0 and a 1, which gives us a network ID of 192.168.5.64. Remember that the reason it's 64 is because the decimal value of the 7th bit from the right is 64. The third possible subnet uses a 1 and a 0 with a network ID of 192.168.5.128. And the fourth subnet uses two ones with a network ID of 192.168.5.192. As you've already seen in this example, the fourth octet is the one where the host ID begins. This is known as the interesting octet. If we borrowed the bits from the third octet, that octet would be known as the interesting octet, since the host ID begins with it. One thing to understand about subnets is that with each bit you borrow, there are fewer hosts available for each subsequent subnet. To determine the number of hosts per network, we use the formula of 2 to the power of y minus 2, where y is the number of bits in the host ID. On our network, we have 6 bits in the host ID, so 2 to the power of 6 is 64, and minus 2 gives us 62 available host IP addresses in each of the 4 subnets. The reason you have to subtract 2 is because the first IP address is always used to identify the network ID, and the last IP is always used as the broadcast address for that subnet. Let's see how these calculations work for our network and its subnets. In our first subnet, our network address was 192.168.5.0. This gives us a host IP range of 192.168.5.1 through 192.168.5.62, with a broadcast address of 192.168.5.63. Each subnet follows this same pattern. Just always remember that the first subnet network address ends in 0 instead of 1. To see this in binary, the host portion in green starts as all zeros. This will always be reserved to represent the network ID. In this example, that's 192.168.5.0. To find out the first usable IP address in the subnet, use all zeros with a 1 at the end. This would be 192.168.5.1. Then, to find the last usable IP, use all ones with a 0 at the end. This would be 192.168.5.62. That leaves all ones to represent the broadcast address, in this case, 192.168.5.63. This same pattern continues as the network ID increments. The next network starts at 192.168.5.64 is the ID, .65 for the first usable ID.
I'm going to stop it right there because it can get kind of cumbersome, but this is subnetting in a nutshell. So to answer your question, you are going to, in your DHCP server, you'll create a pool of IP addresses, and that's based upon need. Okay. You use this formula to determine your need. 2 to the 6 or 2 to the, we normally say n, he got y, but 2 to the n minus 2 is what we're going to use to determine our need. And you use these values. So this is the first bit, this is the 32nd bit. Then we'll go backwards where this will be 1, 2, 3, 4, 5, 6, 7, 8. So 2 to the 8th power, 2 to the 4th power, 2 to the 6th power minus 2 will give you the number of hosts you can have. When you use these calculations, and you'll have to calculate these, I believe, on the Net Plus. I didn't see any on the A Plus. You may, and it only may be one on the Net Plus. I think the guys I taught last semester, when they took it, I don't think they saw any that they had to convert. But I know when I took it, I had a couple I had to convert, and that was in 2019. But you create a pool of IP addresses in your DHCP server, and then but that's determined on your need. So if you see yourself growing in the future, then you'll have to renegotiate your contract with Verizon, or you have to, or Comcast, or whoever controls your internet. So we'll kind of, it's 3:43. I'm over the time. And I don't know, we go to 4, don't we? But anyway, are there any questions?
So far, so good on my end.
No question for me. So
Okay. All right, cool. So I want y'all to continue to go through this chapter, read the content, go through the content, come back with questions if need be, and we will definitely try to pick this back up and get right back where we started on Monday. So this kind of I want you to walk away understanding as much as you can. This is a growth process because a lot of stuff really won't kick in until later, maybe even years later. It took me years to understand some of this stuff. But since there are no questions, everybody, don't forget to complete your assignments. Some stuff like I was telling Gila, we will do in class. And we have lecture day and lab day, but I'm trying to get us caught back up. All right, everybody. Y'all have a good one. I will see you on Monday.
Monday we have it will be online.
No, it'll be online.
Okay. All right.
Yeah, it will be online.
Okay.
All
All right.
right.
Thank you
Okay.
very much, Professor. I
You
hope
have a great.
your daughter feel better.
Thank you so much. I truly
Yeah,
appreciate that.
yeah. Keep her prayers.
I really appreciate that. Thank you so
You
much.
no problem.